Good morning, Wonder Woman of the world. Hello, dear Golden VIP members watching live and dear do-it-yourselfers watching the replay. We have week 2 starting. Please type in whether you're watching live or the replay. What have you done this weekend in terms of coding? Did you do any Python? Did you attempt any of the hackathon? Perhaps did you go to some local event and code it with others? What have you done this weekend? Wow, Monica, Kat, Roxana, Marta, Christina, Libby, Virginia, Afson, Anna, Tikviza, Nikki, Writing Renditions, Luis, Alj, Sarah, Katya, Maya, hello, good morning. All right, we have 3 things to cover today, so I'm going to jump straight in. This is actually week 2, day 1 of the Summer of Code, and this week we're following along there it is. This week we're following along the Learn Python the Hard Way by Zach Shaw and adding the secret sauce of testing to the mix. Something very cool that is pointed out in this book, which I call meta skills, are that beginner coders can improve on 3 basic meta skills that are not exactly about programming per se meaning it's not directly about it, but these are really indispensable. You cannot do without them. And these 3 are reading and writing, attention to detail, and spotting differences. So reading and writing is very, very helpful. If you read a piece of code and you type it in yourself, that's when you will realize all the little details of the colons, the semicolons, opening and closing brackets, the spacing, and so on. Attention to detail is always something that we can improve upon because the program does what we tell it to do and not our wishes. And number 3, spotting the differences will make your life so much easier because in reality, about 80% of your time writing code is spent on debugging. Let me say that again. About 80% of your time is spent on debugging. People overestimate how important the writing skill is. Yes, of course, you need to write code, but the truth is you'll be spending a lot more time tweaking it and getting it to work the way you thought it should work. So, can you spot the difference, everybody watching? What is the difference between the first and the second here? Feel free to go ahead and type it in. So while you are typing in what the difference is, I will quote for you a little bit from the introduction that was modified. When you study and continue with your programming, please remember that anything worth doing is a bit difficult. Very good, very good. Okay, Nikki got it, Libby got it, Erin got it, Katya got it. Excellent. Tikviza, I completely agree. I have actually 4 screens here. 1 for, well, 2 for broadcasting, 2 for working, and I also have some backup options in case I have a Linux machine in the background, and to be honest, a very old iPad with a keyboard and my phone with an external keyboard. So if I really, 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 really need, I can do 1, 2, 3, 4, 5, 6, 7 screens. Yes. I don't quite use that at the same time. When I was in banking, I would use 6 screens actively. White space, yes. Yes, yes, white space, absolutely. So Python is very unforgiving. Rux Artin has a good point. Other languages are much more forgiving, including JavaScript. You can have a lot of empty space without really messing up. But Python, because it uses spacing in order to understand the hierarchy of your code, what's within each step, it's very unforgiving. Yeah, so for example, this second one here will throw you an error because you're missing the indentation. Also, I'm using just two spaces at indentation. I'm thinking I should probably go back to the standard, which is either 4 spaces or a tab, and work on it. Okay, let's talk about difficulties. Maybe you're the kind of person who's afraid of failure, so you give up at first sign of difficulty. Maybe you never learned self-discipline, so you can't do anything that is quote-unquote boring. Maybe you were told that you are gifted, and so you never attempt anything that might make you seem stupid or not a absolute prodigy talent. Or maybe you're a competitive person and you unfairly compare yourself to someone who's been programming for more than 10 or 20 years. Whatever your reasons for wanting to quit, just please keep at it. The author here said, force yourself. I would say play with, instead of force yourself, let's say, instead of force yourself, play with it. I don't like forcing. Just play with it. If you run into a study drill you cannot do, or a lesson just don't understand, skip it. Feel free to skip it and then come back to it later. Just keep going. What matters with programming is that you keep on tinkering. At first you might not understand it. It would be weird, just like learning a human language. To be honest, you might struggle with words or symbols. And sometimes you might not have the vocabulary to find on Google your answer, and that's fine. But then one day, bang, your brain will snap and you will suddenly get it. So if you keep doing the exercises and keep trying to understand them, you will get there. Some really good comments here. Yeah, Python as the code is really tight and makes it more readable, Christina Tarantino says. Line 30 versus line 22. I love it. I love it. Roxarton is really specific. She told us which line versus which line. You see, so she read here the line number and quoted that. Fantastic. Well done, everybody. Give yourselves a round of applause for your first check. So this is always true in the summer of code or in learning anything, to be honest. If you're doing, do not copy and paste. Type each of the exercises in manually. If you copy and paste, it would almost be better not to do the exercises, because the exercise is to train your hands, your brain, and your mind how to read, write, and see code. And believe me, it's that typing mistake is what you will remember the most. You know, if you spend, I don't know, 10 minutes trying to figure out why something isn't working, that's the one you will remember. So if you copy and paste, you cheat yourself out of the learning experience. Please type it in yourself. And this is a section that's not included in the Python the Highway. I thought I would give you a parallel between week 1, Introduction to Python, and this, because in reality they overlap a lot. Because the body of programming and Python itself is limited. It's a limited universe of knowledge. And so there is overlap between these two first 2 weeks because there is only so much that is included in basics of coding. It's, however, great because you get to do more exercises, you can practice more, and you can see how the same concepts are presented and applied by different people. So I wanted to highlight the similarities for you so that if you need help with any topics, you can know where you should go and where you can go. And there are 3 basics. There are the tools you're going to use, there are data types, and there are language basics. Oh, Roxarden says coding isn't boring, it's magical. Yes, yes, I'm going to give you a big thumbs up for that, Rox. Awesome. So the tools in both cases are the same. You have 3 tools: your text editor, your terminal, which has many names. People call it the shell, the command prompt, command line, other names. And then you have Python. With these 3 tools, you can program anything in Python. Now, it's not often said, but I wanted to say that having a good grasp of your file manager is helpful. And especially, I would say, on Windows, where they try to hide it from you. Sometimes it's a bit difficult because they don't expose your file system to you. And yet it's so important to know where your files are and what your hierarchy is. And it's not just about the code that you write, for example, but also where everything is installed, and where are your systems files, and if you have more than one installation, how do you switch between them? So actually, I think that getting a good grasp of your file manager is good, and sometimes it's worth even to spend a little time Googling and studying that. Excuse me. Of course, this can be accessed through the terminal. So you can do change directory, make directory, list out what's in there. You can make new files. But for the beginner, I think it's helpful to see it visually. Exercise 0 is a detailed setup chapter. So I'm not going to ask, there's nothing in this course where you have to actually buy the do Python the hard way. And they have a free preview that includes a little bit of each chapter if you want to look through it. Roxarton is talking about, yes, PHP when you add extra spaces. So let's talk. We talked about the tools. It's those 3 basic tools, and in exercise 0 here you have a detailed setup chapter where it goes through the Windows, Linux, and Mac setup. It uses a little bit of a, well, he likes Atom as a code editor, and I'm using Sublime Text, but other than that, it's basically the same. It's really nice because it teaches you some basics, and if you are in the Python 3 version, it gives you Python 3.6. You see, this is the problem with any technology. We're already on 3.7. So the versions move so quickly, it's practically, it's very hard to keep up with. Okay, data types are the second part that are overlaps. What are data types? Well, we started with numbers, and then we went on to strings. And we also learned something about Booleans. Booleans is a fancy name for true and false. There are only 2 kinds, true and false. And we saw a little bit of lists last week. This week we're also going to look into dictionaries and objects more in detail. And finally, functions. Functions are a very special kind of object because they can do things. And they can do really two kinds of things. They can either return values to you, or they can also have side effects. Meaning they might not return this value to you, but they might change something in the background. Okay? Sort of rearrange your kitchen. They can affect other objects as well as input and output devices, such as your screen. So exercises 1 through 12 in the Learn Python the Hard Way work on numbers and strings, and then exercises 13 to 26 you're introduced to functions and files, and we will do a little file manipulation today. Exercises 30 to 42 go over lists and dictionaries and introduce you to more advanced topics such as modules and classes. And finally, the language basics. The language basics remain the same. In some way, here in about 100 lines, I have given you the basics of any programming language. It's your tools, your basic data types, and the language basics. And in Python, as in many other languages, loops and control flow. These are the 2 tools that you have to manipulate the data types you have. Loops, we did for and while loops, and the control flow is the if, else if, and this type of branching that you can use to handle different cases. This is why programming is different from, for example, HTML and CSS. Because unless you script those, for example, CSS can be scripted, but actually if you script it, you're already programming. But static HTML and CSS, you don't have control flow. You don't have loops. You cannot have logic because it's static. It's just like a document. Okay, and that's the difference. So for example, also here I am showing you this day1.md markdown. This is a static document. It cannot execute anything in .md. But we're going to program today, and our .py can actually execute things and run. That's the difference. Okay, so towards the end here, exercises 27 to 33 give you a lot of detail about branching and logic. It's quite in-depth. And then towards the end, you're going to create your first website, you write a game, and have introduced some more sophistication into your code by using object-oriented practices, automated testing, and modules. I understand some of you already looked ahead, and also maybe for the last few weeks have started working on the Learn Python the Hard Way. Can I get in the comments, please, whether you're watching live or the replay, how far you have gotten? So if you started self-study with Learn Python the Hard Way, which exercise, chapter have you gotten to? I know some of our volunteers, core volunteers, already gotten to about 17 or 18 on their own. And so I'd like to make sure. Chapter 17, well done, well done, well done. Good. Well done, not yet. Okay. The week is structured so that no matter where you are, you will benefit from it. And you can use the book as extra practice, or you can use the book as the guiding principle and then use the course as extra practice. So it really depends on where you are. You wanted to make sure that both groups, those who have started and those who haven't started, can use the course. Okay, cool. Let's get started then today. And I wanted to talk about 3 things. Today we will cover functions, testing, and reading and writing files. Are you ready? Yes. Yes. Awesome, Andrea. Let's have a look at functions. So the first function that I wanted to talk about was the move function. I think we asked you to create a function that would return move n times. So we start every function with the keyword def for define. I can make this a little bigger, I think, right? Is that helpful? Yeah, good. Yes, commenting is very good. In the end, you also want to get to the point, Rox, where you only need to comment those things where you have to make a decision or where it's not obvious, because ideally you would like to write code that documents itself. Does that make sense? Like you want it to follow best practices so that anybody reading your code knows what you're trying to do. There are competitions out there for fun where you try to write code in as few characters as possible. And there people will write things that you cannot read. I mean, it will be just like very short little tricks. But that's not the goal in real programming. When you are doing this for a long-term benefit, remember, code is read 5 times more than it is written. 5 is code read 5 times more than it is written. And so it's very important as much as possible to self-document. So this is what we asked you to do, is we asked you to print move n times. How many of you had this? Let's run it and let's talk about Python code in general. So if you open your terminal, you see here I'm in my home directory, so I need to move, and I'm going to change into, I specifically put things in my repos. Actually, I need to go to my Dropbox. Cool. And then I go to my repos. And then I go to Toolkitten. And then I go to Summer of Code. And then I go to week 2. And you see I'm already working on it. So now we are inside of Summer of Code, inside Toolkitten, inside week 2. And I have a lot more things than you, but that's okay because I'm going to push this up. So we want to run something called day1.py, right? Right now all it will do is, what will it do right now if I run it, by the way? Well, let's run it. So we'll do Python day1.py. Anybody know what we'll do? Very good. It won't do anything. Absolutely. Why? Because we defined our function, but we didn't actually call it. So it's not doing anything, right? Cool. So that's cool, but it's not quite. What we really want is we want to call it. And let's say if I call it 0 times, it will output what? It will output an empty string. Actually, it's there. Well, it's not bad, but not too helpful. Let's also run it for 1 and 2. You see, each time when we're running it, I'm passing in what is called a parameter into the function, into the brackets. So I want to do this once and twice. It will take number 1, put it in here, and execute. Let's save it and run it. And now we're getting there. So we have an empty string because 0 times anything is empty string. Then we have 1 moo and we have moo moo. What's the difference between defining and calling? Very good point. Well, they're completely different. When you define it, you are creating it and making it available, but it's actually not running. So if I run day 1 now, nothing actually happens. It's a little bit like, imagine like architecture. So defining it is like creating the blueprint, but the building is not there yet. And when you call it, that's when you actually build, and there is building. Or think about cooking. So defining it here is just like writing out the recipe, and then calling it is like cooking the food and making it actually happen. Did I save? 1 second. No. Let me bring this a bit higher. Cool. So that's the difference, is you have to first define it and then we have to call it. Majestic Casual, very good question. Good. So this is helpful, but what if I wanted to, if I don't, you know, do you remember our mantra, which is that programmers have to be lazy, and not just lazy, but aggressively, proactively lazy? So as you see here, I typed the same thing 3 times. It's not very good. We don't want that. Instead, what we want to do is, let's say if I wanted 0, 1, and 2 times, who knows how could we do this with a for loop? So I want to run moo 0, 1, and 2 times. Let's do this with a for loop. For I in range 3. What does this mean? So it will do it 0 times, 1 times, and 2 times. If you remember the default for a range, if you don't give a first one, it will go from 0 and it will increase by 1. So if we run this, we should get the same result twice. Excellent, we tested it, it worked. So now we can comment these out and have our beautiful and lazy version of testing. Now this is not bad, but for those of you who are already about, you know, chapter 17 or so, this is not quite enough. Let's jump and let's talk about testing. So automated testing is when you know your outcomes, you know your inputs and outputs, and you want to make sure that your program behaves the way you expected it. Today I'm going to just introduce it, and we will take on, not just this week, actually probably for the rest of the summer of code, until you really get a feeling for how powerful this is. So if you see here, there's day1.py, and I have a test underscore day1.py. Right now it's completely empty. So let's put something in it. We need to import the unit test module from Python. This is the syntax for that. What does this do? Python comes with a very, very nice standard library that others already have written that have various functionalities in them. Thousands, tens of thousands, maybe millions of lines of code. But they fall into basic categories. And somebody was kind enough and they already wrote a testing module for us. It's called unit test. So we'll just import it, and this way we don't have to write our own. Also, we will import what we need to test, which is from day 1. Do you see moo here? We need to import that in order for it to be available in another file. And the way to do that in Python is to say from what file, from day 1 file, import what? We want to import moo. What this does is it will go into day 1 and import this function here. And now we can run moo. So let me show you that. If I don't have it, and I try to run moo 2, we should error out. Let's try it. So Python test day1. You see, it says error, line 6, name moo is not defined. Testing. We must import the function that we are testing. Otherwise, we'll have an error. I see you don't see that bottom. Let me just raise this up here. Good. Yeah, it didn't like it. So how do we fix that? We fix this by adding the import keyword. If I do this, it will still complain because I called the function before I imported it. So even though it looks almost good, it still doesn't like it. But check this out. If we do this now below, after we have imported moo, now it works. And what's nice about it is I'm actually in a different file from where moo is living. This is how you can pass functions back and forward. Awesome. Good, good. So now that we know we have access to it, we can start testing it. And this is something that for now you just have to memorize, okay? Because we haven't covered classes yet. If you've covered classes, it's fine. So we will create a new, call it a container. It's called a class here. And I'm going to call it test moo. I want to, why? Because what it does, it will test moo, okay? And within it, we will have several tests. So let's have a 0 case. And what it will do is it will check, it will assert whether moo0 is equal to what we want it to. So what do we want this to be equal to? We want it to be an empty string. We wrote our first test. Congratulations. We are testing if I call moo0, whether it will actually give me an empty string. Now, in order for it to work, you have to actually instantiate. So you do unit test dot test case. This for now, please memorize. What's happening if you're more advanced here is that from the unit test, we are actually saying, hey, this is an instance of test case. And this way we are able to use the assert equal method here, which compares an input and an which compares the output to the desired element. Okay, so it's very good, but again, it won't run unless we actually call it. So unit test.main will allow us to call this whole thing and happen. So let's run it. And we got something that I didn't quite expect. Oh, I know what's happening. Awesome, awesome. Okay, so for some reason we failed the test. Now this is really, really good. Like, it caught me off guard for a second. Do you know what happened here? Let's have a look. I called python testday.py. And it did a fail. So when we look at test 0, do you see here test 0? It called itself. It says on line 13 in test 0, I wanted to assert that m0 is equal to an empty string. But there was an error because I actually got none as my value. And that's not equal to what you wanted it to be. So it tells us, this whole class here told us, this Python code, that I ran a test for you in 0.003 seconds and you failed the test. Why did the test fail? Very good. Awesome. Awesome. TW Ho 37 and Roxana, absolutely. So this is the difference between the side effect and the return. So we had a side effect, we printed everything out, but actually the function didn't return something. So we need to return the result, and that is the same times n. Okay, let's run it again. And now it works. So we ran the test, and it ran beautifully. Cool. Now, to be honest, we did a little testing down here, but what we want normally is to test a few of these cases. So not going to do a lot because it's a very simple one, but let's do a few. So we'll do it for the case 1. In this case, self.assert equal, we want to know that mu1 will be what? It should be mu. Awesome. And so on. Define test2. Self.assert equal. I'm repeating the syntax. So if you don't know this syntax, this is how you learn it. You try it. Okay, and let's do one more. We don't need too much because in this case they are all the same. Just to show you that you can have more than one test, and this is how you create them. Assert equal mu3, mu. Okay. So now I have 1, 2, 3, 4 tests actually. Let's run them. It ran 4 tests, and it's wonderful. Let's see if we could, if I remember correctly, is this how it is? Let's just try, sorry. I wanted to have a little more language coming from it. No, it doesn't like this one. It's okay. We will do this tomorrow. I don't remember the syntax, have to look it up. So we ran these 4 tests. Let's have a look though. What if we make a mistake? So there are 2 options. One is that your tests are wrong. Your tests will usually, I think, are less likely to be wrong, but maybe your test is wrong. So maybe you mistype, and it's the mu you wrote 0, 0, or mu. Okay. Now the test is wrong, so it will fail. And it's a little bit interesting because it shows you when you fail. So it says here, fail test 3, trace back. Line 19, it's really kind to you, it tells you where. It says, I got mu, but that's not equal to mu at sign. And it shows you, this is what you got. Here's a problem. This is what you should have gotten, and they differ. Okay. This is not as likely as the next scenario, is when your tests are correct, but maybe your code isn't. So let's say this was your intention. You wanted to return mu times n, but actually maybe you made a mistake and you're returning n plus 1. So what happens? If I write mu 0, it returns 1. If I write mu 1, it returns it twice. If I write 2, it returns it 3 times. Okay, we totally broke the code. Let's have a look now what happens. Did I not save it? Let's see. Good. So it scrolled off the screen because there are so many. But this is really nice. Have a look. So it ran mu, and then it ran the test. And it has a, little, a capital F here which says, should I make it bigger? It has a little capital F that says, hey, fail, 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 fail. So we miserably failed all of them. But that's awesome because now you actually have a way to look at it. And please believe that once you start having tens of files, maybe hundreds of files, and you have tens and thousands of lines of code with 20 or 100 people writing, you really want to make sure that their code doesn't break yours before you accept it. And this is where unit tests are so powerful, and this is why in Agile, if you've ever heard the keyword Agile, you actually need these tests, because what they do is they protect your code from being broken. If someone's code passes your tests, you know they haven't broken your functionality. So let's have a look. We failed 4 times. Test 0 failed. It got mu, And it says, oh, that's not equal to empty string. Correct. Test 1 also failed because it got moo moo instead of moo. Very good. And test number 2 also failed. It got moo 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 instead of just moo moo. And so on. So it tells us the difference. We got moo, 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 moo 4 times instead of just getting it 3 times. And it shows you what it got, how it was wrong. It tries to show you where the location of the problem is. It doesn't always find it exactly. And then it shows you what it should have been. Okay, so now you do your debugging and you're like, oh, okay. Actually, I wanted this to be 0. Okay, cool. So now you go back, you fix your code. And actually, you don't really need the printing. And actually, you don't need the manual testing here. This was more for yourself. And you wrote 2 lines of code. And look at the test. Just to test this, you wrote about, well, 21 minus the spaces. So about 10 lines of code to test it. But it's worth it because now nobody else can break this code. So we ran 4 tests and they all passed. Fantastic. Okay, let's give ourselves a round of applause. And what I would like to ask you is if you already are in chapter 17 or quite far away, your homework then is to go back and start importing unit tests and work with it. The testing taxonomies I will push up, they are here for you in Python. And I'm going to also give you the actual Python reference for unit test. Yeah, testing taxonomies and the Python unit test reference is here under docs. Have a look. You don't have to understand it all. It's more that you start understanding what's happening. And the only thing we did today was a test case. We didn't worry about fixtures or suites. And we did run the tests. But for now, just we are using the test case. And this is what we did. Tomorrow I'll explain what this main is, or if you read ahead in your Python course, you know that there is a global namespace in Python. For now, we simplified it by just calling the unit test directly. Okay, so for more advanced people, your homework is to write unit tests for yourself for the previous chapters that you've already completed within the Learn Python the Hard Way. If you are a complete beginner, then you are just going to stay with Moo and enjoy. Okay, so we did the testing. C test day1.py. Excellent. And now let's talk a little bit about reading and writing files. Ha, 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 ha. This is very important because in the end, what we want to do with all of our coding is to answer interesting questions, to grab things from the internet, right? To work on files that are on our computer. Yes, you will need last week's day 4 to get introduced to functions. And this is building on week 1. So either you self-studied, learned Python the Hard Way, or you already went through week 1, I'm assuming, because we're going a bit faster here. Cool. You'll have all the code to play with, and you're very encouraged to break it and completely rewrite it, and so on. Okay, so let's talk about reading and writing files. I have a beautiful little file for you, which I downloaded from the Gutenberg website, where they have digital books available. So we are going to have a look at Alice in Wonderland. Alice in Wonderland here in week 2 lives in a text file. I don't know why, but it doesn't. Cool. You'll see this is Project Gutenberg's Alice's Adventures in Wonderland. And it's very nice because they have actually typed up the whole book, and it is only 3,737 lines. I'm joking about the only. Yeah. So that's awesome, but what do we do with this? Because we actually want to be able to read it in and do something with it. So let's say we have an Alice in Wonderland.txt. How do we read and write these files? And Catalin says, at least it took me 30 minutes to get lost, not like 15 like on Wednesday. Well done, Catalin. You're awesome. Okay. Let's jump into the file reading. This also works actually when we're reading for the internet, so your skill will be transferable, which is quite nice. Let's tell the computer what the file name is. Our file name is Alice_in Wonderland.txt. And I know this because I opened it, and I also know this because I looked at it in my file manager. If I could bring this up. Oops, let me just... Yeah, so in week 2, I already saved Alice in Wonderland here, and I'll push it up for GitHub for you to play with. It could be any file, though. You could open your own. In fact, that is probably the best way to do it. So we have Alice in Wonderland. That's awesome. In order to work with it, though, we have to load it into our program. And the way that works in Python is with the open function. So we're going to open this file here, and we're going to set it to be read. You could also write files, but for now we're just going to read them. And then for line in file, let's see if we can print. This will be very long. It will scroll a lot. Let's see if it runs. And it's not test, it's day 1 with everyone. Wow, there we go. So did you see the magic in this? We just took a file from the internet, or you could write it locally. It's a text file. We opened it in our Python code, and we had it print line by line to the page. For line in file is a loop, and what it does, it actually just steps through, finds every new line character, and does it for you. And wow, we read Alice in Wonderland twice. Shall we read it one more time? Let's read it one more time. Awesome. This is good, but you can only print with it. The truth is, sometimes you actually want to work with it. So let's do something, this is quite common to say, which will be a raw text object, string object inside your memory. And what you do is you read in the file. Actually, this I think won't work because now we'll be at the end of the line. Let's have a quick look here. Yeah, because it's at the end of the line. So you'll need to comment this out. We don't want to actually do this. What happens when you do a for loop like this, it opens the file sequentially, goes to the very end of it, and by the time you get to the end of it, there is nothing else to read. So we don't want to do that. That's much better. Okay. And so what you really want to do is open a file and then read it. And now you have access to it in an object, well, in a variable called raw. What I did here with the 65 is I went from the beginning, or 0, up to the 65th character, and I printed it out here. Project Gutenberg's Alice's Adventure in Wonderland. And this is how you read files. What can you do with something like this? Well, a lot, because now if we have raw, we can actually do lots of other things. So we could go from, okay, so this is what we did. We went from 0 to 65. We can also go from 65 to 500 and so on. I might have to do a print. Let's have a look. Yeah, it won't do it without a print. Okay. And you can start exploring text files that you either had locally or that you had from the internet. The first one was 0 to 65. The second one again was from 0 to oh, that's interesting. I expected it to have twice. Let's add something. Okay, from 0 to 65. Again. Let's have a look. Okay, that's good, yeah. So from 0 to 65 is here, but when we did it again, it went, what's happening here? Huh. We are getting different length. Here it goes to C, and here it goes to Carol. And then from 65 onwards, this is for 500. This is very interesting. Well, I guess some debugging needed here. But what I wanted to show you is a few things, because now that you have actually read this into memory and you have raw as a variable, you can do things to it. So for example, shall we count the length of raw and print it? The length of Alice in Wonderland in this text file is, and you can actually calculate it this way. Can't convert int objects to string implicitly. Well then, let's is that what you're complaining about? Cool. Yes. Okay. So we now know that there are 163,817 characters in our raw. And this is really helpful because now we can do things like read from behind. Like we can do raw minus, I don't know, 163,000 to the end. Well, actually, that's not helpful. Let's do something like this. So to this will read as the last 817 characters. So here are your exercises, should you choose to accept them. Is calculate a table for each letter in the alphabet from A to Z and count how many times each letter appears in Alice in Wonderland. So you're going to go through this text and count how many little a's are there. You should end up with something like little a's. There are, I don't know, there are maybe 34,560. Little b, there are, I don't know, 5,027 of those, and so on. And then little z, you will say there are, I don't know, 893 of them. This I totally made up, but this will give you this initial exercise to look through a text and start exploring within it. And actually, with what you have learned so far, you're capable of doing this. Very good, Roxana, Jesse, good. New favorite icon. I love magic. Oh, wonderful. We have unicorns for magic. You need these reading files. Yes, very good. So actually, to be honest, this counting of letters will be also helpful to you for the hackathon challenge with the Boggle, because we will be working with dictionaries. And before I introduce dictionaries tomorrow, it would be great is if you could get a little bit of practice in this type of, the fancy word for this is frequency distribution. Okay, let's just say it. Fancy word for counting stuff is frequency distribution, because you're counting the frequency of something. So, cool. That is it from me. Let me recap what we did today. Because it's your choice whether to get or not the Python the hard way, and it's already an existing book. Instead of going through each exercise individually, what I'm doing is focusing on the areas that are applicable and have long-term applicability. So today we looked at functions and parameters. Then we looked at reading and writing, testing, and then reading and writing files. And there's one more very important thing that I'd like to do before we wrap up, which has to do with functions. So let me do it maybe under the function heading here. And that is when a function calls itself. Are you ready? Can we get some drum roll in the last few minutes? This is what we're going to do. Is if you read Learn to Program by Chris Pine, we're going to ask a question of the user. And we keep asking until they give us an answer that we like. Okay? What does this do? Well, let's check this. We will store the person's reply in the reply variable, and we will ask them to input an answer. I'm going to set their answer to lowercase so that it doesn't matter whether they type big or small. And we will only accept yes or no. So if the reply is equal to yes, we will return true. Oops, why did I do that? Yeah. If the reply is equal to no, we'll return false. But what if the girl who we're asking for an input, we're asking this question, doesn't say yes or no? We're going to tell them, hey, if you said something other than yes and no, I'm going to say to you, please answer yes or no. And we're not going to accept any other user inputs. So check this out. What I'm going to do is if the person says something other than yes or no, I'm going to just do it again. I'm going to ask recursively the same question until it works. This is a bit quick because we're short on time, but let's run it. How many of you have read Chris Pine's book last week? So he has this question about psychologists asking you about Mexican food, but in reality they're doing a test for bedwetting. And so the psychologists are asking you, do you wet the bed? Excuse for the example. This is the question that they are asking. Okay, so let's have a look. It says, do you wet the bed? Can you see my, oops. I want to make sure that you can actually read it. Uh-oh. Here, good, good, good. So, it says, do you wet the bed? This is the question. And I'll be like, well, of course not. But it doesn't accept my answer. Do you see what's happening? It says, please answer yes or no. Do you wet the bed? So it asks me again. I say, what? Please answer yes or no. Do you wet the bed? Hey, come on. Please answer yes, do you wet the bed? So it won't allow me to do anything, and I can't get out of here unless I answer yes or no. because everything else, if I do, in any other case other than yes or no, I get put back into this function. So in some ways, we created our own loop. Do you see this? It's not an infinite loop because there are two ways out. There are two return statements. I can get out of this, let's say, hell, by answering either yes or no. But we created a loop by asking the same thing again and again. We're calling ourselves here. Do you wet the bed? Okay, so I'm going to say no, please. And even though I capitalize it, because my function will make it into lowercase, it should match into no. And voila, I'm out. The rest of the program has completed and we're out. And you will need this recursiveness, a function calling itself, both in the Buggle solver and in the continent counter. So I wanted to introduce it briefly. And honestly, this is a topic, recursion is a topic that you will see for weeks, for months, and for years in your life. And the more math you do, the more you will look at it. But this is our first introduction to a function calling itself. Thank you so much. There was a lot, so let me push this up for everybody to play with, and then we will see you for the Q&A. Thank you. 4-minute break and see you there. Well done, everybody. Very good.